the foundation because the foundation will be static foundation is smooth. Even shallow foundation, no? But designing of foundation structures such as footing, that's our topic because we are mid of reinforcement. Okay. So what are shallow and deep foundations? Shallow foundations are commonly used for smaller projects or smaller buildings, no? Meaning, kaya ka kay sa yuta, no? Just like, tungtong ka sa yuta, dili ka mulubong, no? Pero kung adto ka sa mga humok building na yuta, mulubong yung kataman sa tuhod, no? Tungkol sa kahumok, mo, kay, abot yung mga, kanang mga humok yung kayo, mga pita, mga nakabasakan, lubong yung ka, no? Pero kung, so, ordinary lang ang mga yuta, so, kaya kay kasayuta, no? Kaya kasayuta. So, shallow foundations are commonly used for smaller projects and when top layer of soil can adequately handle the distribution of weight. So, muna siya, shallow foundations are for smaller projects so, such as 2 to 3 stories building. So, kung computer nimo yung weight, gamay ra yung weight niya. Computer sa nimo ang soil bearing capacity sa soil, so, ayan na. Nya, kung dili makaya, so, magbuhat kag improvement just like compaction. Nya, kung dili pagin makaya, that's the time you resort to the foundation. Kung saan na yung deep foundation, doon na kay mga extension ng mga structure, isumpay sa imong itawag nga footing, paingon sa firmer strata or bedrock. And what are these? These are called piles, no? Or shafts. So, that this is not our topic. Our topic is part of the shallow foundation. Now, footing belongs to shallow foundation. So, what is a footing? Ako ning gyud din sa Wikipedia. No? Footings are an important part of foundation construction. They are typically made of concrete with rebar, meaning it's reinforced concrete with rebar reinforcement that has been poured into an excavated trench. The purpose of footings is to support the foundation and prevent settling. So, if your building is heavy and then you do not design the size of the footing, there is a tendency that it will settle. No? It will settle up to its equilibrium. Okay, so good if the the building settles uniformly. What if the north portion settles more than the south portion? So you have a building that is tilting. So if you put a ball in the middle of the floor, it will go to the other side. Why? Because the building is inclined. No, why is that so? Because the uh, other part settles other part settles more than the other. So after how many years, let us say 5 or 10 years, you will see that your flooring is a bit inclined. Okay, and if you put a bowl inside in the middle, the bowl will just roll to the other side. That means that oh, this is already uh, the flooring is already inclined. So that's how it is. So uh, that one is not a good picture for a building that has inclined flooring. So what you do is you have to design the footing. So you can adjust the prevent settlement because settlement really is there, no? Because just part of that is part of the how the soil reacts. So, but you can control the amount of settlement. There is what we call allowable settlement. Like for example, usually in construction, we allow a settlement of about 25 mm. So only one ends, no? So beyond that is already is not already tolerable, no? Especially to the owner. The owner will always complain, oh, why my building settles like that. So uh, but there is no such thing as no settlement. There is only what they call tolerable settlement. So you can, like for example, using smaller footing, you will notice that uh, if you use a lesser area of footing, you have more settlement. Let us say your settlement becomes 3 inches or 75 mm. That's bad because that's more than 25 mm. But because you use only, let us say, one by one footing. But if you try to increase it into two by two, you'll notice that the 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 settlement reduced to about 20 mm. So, then 20 mm is within 25 mm tolerable settlement, then that is okay. No? So, but there is also an exchange because you make wider footing just to have a little settlement or to have a what we call bearing pressure that is lesser than the allowable soil bearing pressure. Okay, so there will be a cost implication. No? So if you try to economize, you make it very smaller, then there's also what we call an effect. You're building settles more. Okay, even if you're building settles uniformly, but after 10 years, it's already lower than the present ground elevation. So during rainy season, water can get in, no, in the ground floor, not in the second floor, because second floor is high. So again, you need to repair the flooring. You need to make it higher, and then making it higher will reduce the floor to ceiling elevation. Okay, so tingnan sa ka nga, oh, tumubo ba na itong ceiling, hapit na mata mapakog, no? Just because you raise the ground floor. Why you raise? Because there is a settlement of your building, and it's uniform, it's large. But if you design the footing uh, correctly in the first place, it will not happen like that. Okay. So it's important to design a footing area. Okay. So what are the types of footing? So these are the types of footing. So first, it can be categorized as a spread footing. So this is how it is, spread footing. So kidding niya sa right kind of spread footing. Then you have combined footing. So you will notice that you can ask, kung sa pwede differential sa spread o combined. Maybe ang combined is isa ka footing ang gi-share sa duha ka column. So these are the example of combined footing. And ultimately, we have the mat footing. So mat footing is you have one footing shared by two mini columns. So this is what we call, this is good if you have a basement. So you can use the top of the footing as your parking area. No? Usually, tall buildings have basement. So 3 to 4 level basement is very ordinary for a high-rise building because they need parking area. So below that is what we call mat footing. But sometimes they are if the soil there is not rock, they are supported by piles. No? So that's it. So footings are just like this. No, it's just like uh, kuan kanang tiil sapato no nga nilapad no para di gyud nila madisturbo pa kayo ang soil. Ma-disturb nimo ang soil kung gamay imong puting kay ngano man mulubong man ka kaya ang soil has limited capacity. Labi na wala nimo gi-improve, wala nimo gi-compact. That's why in ground improvement technique, compaction is very important. Okay. So a closer picture is we have this. This is what we call spread footing. This is very common type of footing. No? Sometimes we call it square footing. And sometimes the form is not square but rectangular. We call it rectangular footing. But still it's a spread footing. Okay. This is the footing and this is the column. The column is attached to the to the footing. Now there are two types of structure here, column and footing. Now today we will discuss about design of footing. Okay. Column will reserve it next meeting. So footing. So this is spread footing. If you go back to the types of foundation, so nani siya sa mga premier on spread footing. So here this is a square footing, this is a rectangular footing. So you can easily distinguish what is the difference between square and rectangular footing. So by the form of footing. Okay. So na by circular, okay. Wa may mugbot sa imo kung imong footing circular, but circular footing is uh as uh what uh very tricky to do, no? Because to lay out a circle is takes a skilled worker to lay out it other than a square footing. So this one it's not really easy, but there are times that you cannot really get away by design of this, such as if you are designing a smokestack or maybe a tower, no. So sometimes it's very economical for you to design a circular footing. Okay. Usually smokestack, when you design a smokestack or other one, nga ga self-standing structure, sometimes you insert into circular footing. So that's why circular footing, di gyapon mo wala. But the principle of designing footing are all the same. Do not load the soil greater than its capacity. Okay? Kung imong i-load ang soil greater than its capacity, ang soil madaot. Kaya nga naman, imo man gi-loadan o greater sa iyang capacity. So, kung tao pa na siya, ma sa mitabo sa tao kung loadan nimo siya sa iyang kaya. Padalon nimo sa iyang kaya. Iyang kaya, isa kasako nga bugas iyang makarga, pakarga paalsahon nimo siya og tulo ka sako sa mitabo sa tao. Last. Sa mitabo sa tao, class. Hello. Are you still there? Mr. Santos, na ba ka? Oh, what will happen to a man nga ang kaya niya 100 unsay kuan unsay kanang usual nga kaya sa isa ka tao, like for example uh, mga teenager pila yung makaya nga weight niya, makakaya siya og mga 100, 70, 60, 50 lifting.
50 sakto nga sako sa bugas.
That's 75 kilos. Wow, 75 kilos. So, if that is the capacity, no? Let us say capacity, capacity. So, because soil, doon ay capacity ang soil, no? How are we going to determine the capacity of the soil? It's based on soil exploration. So, mag-investigate, doon ay gitawag og investigation nga mag-investigate civil engineering gyapon, pero he got knowledge in soil and foundation engineering. So, he's going to make a soil exploration and then make some tests in the laboratory and both on site. If he can estimate the soil bearing capacity. Okay? So, muna ang soil bearing capacity niya nga. Once ma-exceed gali na siya, na failure. Ang failure is usually settlement. Excessive settlement ang mahitabo. No? Kaya mo collapse man ang yuta. No? Mura siya og kanang siminto ba nga sample nga i-break nimo, once ma-exceed na nimo ang capacity sa concrete, break siya mana mo break siya, no, tungod kay nabugatan na pag-ayo ang concrete. Muna siyang kasaga kanang hitabo, mutanaw mo sa pag-test niya. So i-compress mo na siya, so ang soil i-compress gyapon na siya. Unsa may mo compress ana niya ang load sa structure. So nga na, no, imagine nimo nga ang soil mo gyapon katong soil kanang concrete sample nga gi test sa compressive strength. Now, kung ma-exceed nimo ang capacity sa concrete, mo-crack na siya, nya mo-crash. So ang yuta nga na gyapon, no? So that's why it's very important nga may bawaan ang soil bearing capacity para ma-alert ang designer nga dili gid niya pasubrahan ang soil bearing pressure niya nga mo exceed sa allowable bearing capacity. You cannot design the size of the footing if you do not know the soil bearing capacity. And if you do not know the weight of your structure. Mo na siya importante, no? So that's very important, no? You cannot plan if you do not have your objective, no? Nga pag-istorya. So you should have your soil bearing capacity first, and you should know how heavy is your structure. Is my 5-story structure heavy, or is my 10-story building heavy for the soil? So that's how it is. Now, how to compute the pressure? No? Yan na din ang area sa puting ni Tabo. Nalitan, doon na ko building nga 1,000 1,000 Newton, 1,000 Newton, no? 1,000 Newton, Newton man ang weight. So, ang weight sa building is 1,000 Newton. Example lang. So, ang capacity sa building is 50 kilopascal. 50 kilopascal. So, kung ang 1,000 Newton nako, butangan nako og 1 square meter, 10 square meter, pila man na siya ka kilopascal ang ang pressure ng imong subject sa soil. So that's 1,000 divided by 10 because pressure is equal to force per area man na siya. Mo ganang equation, force per area, no? The weight of the building, which is 1,000 divided by 10 square meter. Kanang 10 square meter na siya sa about 3 meters by 3 meters kapit. 3 meters by 3 meters is 9 square meter man. O square footing yung gigamit. Now, with 3.1 by 3.1, abot na siguro na siya, no? 10 square. 10 square. Nasa mga 3.162, no? So, ibutan talaga nga 10 square meter yung gigamit. So, 1,000 Newton ang weight sa yung building, ibutan mo 10 square meter na footing area. So, force per unit area, the soil pressure nga imong gi-subject sa soil is 100 kilopascal. Yun sa mga pagkuha ang 100 kilopascal, that is 1,000 divided by 10. That is, soil bearing pressure is equals to the force, the compressive force, or the weight of the building divided by the footing area, that is 100. Now, ang pangutana, if ang soil makakaya lang og 50 kilopascal, mupasar ba siya? Dili. 100 kilopascal imong load sa soil. Ang soil kaya niya 50 kilopascal. Usa man siya class ni mupasar siya dili.
Dili niya kaya, sir.
Dili. So, it's just like ang pangutana ganyan sa imo Mr. Santos. Kung ang kaya sa tao 50 kilos lang, taga-ano mo siya 100 kilos. So, usa may tabo sa tao.
Matumba, sir.
Matumba o malupog, no? Makuan, madaot. Kung kuan siya kanang older na siya, ito si pag sa ako age, o siguro mukha yung spinal column, no? Dili siya kay balo mo lift og weight. Nang magpataka lang wala training, kulba na siya kay makuha ang imong spinal column. So, you should, when lifting a weight, doon naman na siya procedure yun, no? I think I've seen that in kuan nga gamiton ko na nimo imong knee, no? Dili ang imong likod umuwi ang kuan kag weight kay kung in kaso di nimo makaya dili mo crack ang imong spinal column. So imo yung knee kay kusgan man imong knee, pinagko man ang bukog nimo dito. So you carry it with your knee. Okay, you are carrying it, no? So kung siguro kung mga younger pa pwede pa tong mo bend lang gid mo ana, no? Pero generally, in one sa mga safety sa pag-weight sa pag-lift sa mga weight, use your knee, no? Sabi na og mahibig. So, mo nang mahitabo, no? So, at first you know what is the soil bearing capacity before designing the column, the footing. And you know also the weight of the building. Okay? Kaya it's just a matter of area na lang dayon. Pila mo area provide in such a way nga kuan. So, kung ang 50 ang kaya sa yuta nya 100 imong gibutang dili kaya. So, unsa man inyong buhaton? Unsay buhaton nato?
Dakuan ng area, sir.
That's correct, no? O yung kagamayan ang load dili sad pwede kay instead na 5 story ang buhaton, mo na lang akong 3 story. Sayang man ang yuta ang gipalit. So, padayon lang gyapon kog 5 story pero ang buhaton nako dili nako dili increase nako ang area. So, increase na kong area, pila ka ang area, no? So, 1,000 divided by 50. So, kinahanglan siya og 20 square meter. So, kung 20 square meter ang area niya, 1,000 ang weight, divided by 20, okay na, no? So, ang atong objective is ang kuan naman gyud ang allowable soil bearing capacity must be greater or equal to the bearing pressure subjected by the building. Yeah. Kung 20 square meter ang gigamit, 50, okay na, no? Okay na siya. So, kung 20 square meter, kung kuha ko ng square root niya na siya sa 4.47, no? 4.47. Mo na nga, patingala ka, ngano ang puting anay nga kulong, gamay, ang pikas ng kulong dako. Tungod kay sa analysis niya, nakita niya nga reaction adto nga kulong, gamay. Yang isa dako. So, katong dako og reaction nga kulong, kay mag-analyze ka doon na mag-reaction pala for example mo kuan ka mo analyze ka og simple beam kung sa may naa sa yung reaction na kay pin and roller So katong pin and roller mo kung kanaman kung kuan simple beam mo na siya ang ang structure lugar ba kung nagbuhat kag bridge, no? In between is a river, no? Or could be a highway. You're making a flyover. So the flyover structure, which are the girders, are considered as the beam. Now it's only supported on two ends usually, no? In a pin and roller style. So the reaction on the pin and columns are what we call the load to the foundation. Okay. Now you have to design the area in such a way that the soil the pressure subjected to the soil will not exceed the allowable bearing of the soil. Okay. So yung na siya. So if you do not know the weight of your structure, you do not know, you have no idea how to do it. No. So first you have to know the weight of the structure like that. Okay. Let's move forward. Okay, so let's continue. Okay, so footing. This is continuous footing. Gyapon na siya pero giuban na lang niya ang tulo ka column, no. This is continuous footing. And this is the typical mat foundation ang giingon sa iya. Kung bugat na yung building, you can use mat foundation. But di pa gini siya maoy ultimate. Ang pinaka-ultimate pagid is katong deep foundation. Hindi makaya sa mat foundation, then you have to resort into more expensive foundation, which is deep foundation using piles. But kung makaya ang mat foundation, okay. So in actual, this is it, no? You have a column. This is how it is being reinforced. Okay. Gini siya gidouble na yung reinforcement na top ug bottom. Okay. So meaning nag-support siya sa tension, gisuportahan sa niyang compression side. Like this. These are rectangular footing, and this is the combined footing in actual. Okay. And this is a strip footing in actual, or continuous footing also. Okay, so that's how it is. So, steps, no? Steps in designing footing. Steps in designing, let us say, spread footing. Spread footing na sa tasugod. Okay, this is pinaka-common gini spread footing. Spread footing. Okay, ako i-outline. Ano na itong gamay lang. Gamay lang ni siya nga steps. Hindi na ito daganon kay dagan na ito malimot na. No? Ito na siya. Okay. Number 1. Magbuhat yung ganang table lang. Table. Dapat no? Dapat. No? Okay. Number 1. Design proportion. No? Proportion. Proportion sa proportion the area, the putting area. Putting area. Putting area. So, how? Your kuan if QA is allowable soil bearing bearing capacity. Let us say capacity or resistance. Now I will make this a small q because that's how it is. And I will make that. If that is it, and let us say Q actual is equal to P divided by A area of the footing. Let's say footing. Ato lang nabutangan o o subscript ni siya P of the column, load the column. Anong column man? You see here, sa picture, na column nakatat sa footing. So, ang weight, ang load aning column mo, yung mo na itong designing pressure. So, Q actual of the building is equal to the load of the footing divided by area of the footing. Now, how to do that? How to do that? How to design? How to proportion? You just say QA is greater or equal to Q actual. I will just say allow lang. Allow. Q allow. Actual. Actual. So, siya ko na siya. Ana ang ginang atong kuan. Mo gina siya ang argument. Okay? So I will say that. So example, no? Example. Okay. Find determine the footing area for 2,000 Newton building with sandy soil with allowable bearing capacity of, let us say, 80 kilopascal. Okay. So, solution. Okay, we will use this. Okay, but we are not going to use equal. No, we will not use that one. We will use this one. We will just use the equation, the lowest, because this is a range equal or greater than. So metaboda na niya, this will become metaboda na niya. Mahimo ni siyang 80. Oops. Mahimo ni siyang 80 EPA. EPE is equal to P column divided by area footing. Okay, now there is no column load here in the example, but the building weight could be the column, could be the weight transmitted to the column total, no? So we can take that as 80 PE is equals to 2,000 divided by area footing. Okay, so area footing is equal to 2,000 divided by 80, and that is equal to 25 square meter. So that's it. Area footing is 25 square meter. Now, kung sabay akong gamiton, square ba or rectangular? It depends. Basta kaya ang area 25 square meter. So, na bahala diha. Square ba akong gamiton? Circle. Ikaw na bahala. Basta kaya ang area 25 square meter or more. So, more na requirement. Anyway, ang gipangita is ang area, footing area naman. So, that's how to design footing area. But design of footing area is dili na nato topic. This is a problem of a geotechnical engineer. But you know, we cannot design the reinforcement of the footing without knowing the footing area. So ato na lang giakit din, no. So that is one, no. So pag pupursyon mo sa area, kini ra gid ang imong gamiton, no. Kay mao man ni siya ang atong objective. Okay? Ako na siya butang sa taas, din na siya. Ako butang. So, mao na siya ang pagproportion sa area. So, may tabodan na niya. Doon na kay putting nga very healthy. Putting nga very healthy. No? What do you mean by healthy putting? A putting that does not exceed the allowable capacity of the footing. So tagaan mo load ang tao sa makaya lang niya, no? O gamay, no? Kasi ang kaya niya 50 kilos lang, tagaan mo 30 kilos lang kita. So kaya na niya. So tagaan gani mo yung kaya 50 kilos, siya tagaan mo siya 60 kilos. Ang tao magbutbut na siya, no? Labi na din mo tagag snack. Okay. So sabi niya gitagaan mo tagi silutan na ni, no? Mas mo kung i-times 2 pagin nimo, no? Madaot lagi ang health. Okay? So, that's the thing. So, proportion the putting area, no? That's the first step. Now, you cannot do this without the lavabo, without the the putting the column load or the weight of the building. So, it's impossible to determine the area of the putting. So, if you do not have that, then do not proceed to step 2. So, step 2 is design footing na naman tayo footing area. Ang sa may sunod, footing thickness. Footing thickness. So, design ni mo ang footing thickness. No, human sa footing area, footing thickness asap. So, makadetermine na ka footing thickness, ito na kay volume sa footing. No? So, di man estimate ang atong topic, design man. So, although ma-design na nato ang volume niya, maka-estimate na ka sa volume, pero it has only bearing to cost estimate. That's not bearing of the design. The most important nga i-design na to ang puting para dili siya mabuslot. Kaya doon na gitawag og punching shear, no? So, mode of failure is number 1. Ito na outline. Punching shear. Doon tayo gitawag beam shear. Yung beam shear gitawag na siya one way. Kini siya, kung na one way, nasa two way. Okay. So, mao na siya ang criteria para ma-design mo ang puting. So, kanibutan din. Para doon tayo criteria. Formula niya. So, design the footing by footing thickness, no? Footing thickness. So, doon tayo gitawag og punching shear, no? So, doon tayo gitawag allowable punching shear. Allowable one-way shear, a two-way shear. Punching na lang ito butang punching. Punching shear of concrete. Ang concrete na limits, no? Dili kay concrete ang kana lugar salog, ano salog, no? Yung butangan ni mo weight yung concentrated. Kaya na niya, pero kung dili niya kaya, mabuslot na siya, no? Buslot gina siya. Kita ba mo kanang kasada nga gibuak? Yun sa mga nagbuak class ng kasada.
Gamit ko sir, breaker sa excavator.
Breaker. So pag break niya, mabuslot na iwan na mabuslot, di ba? Mabuslot siya tungod sa grabe nga pressure. Now, samot na kung nipis imong puting. Kay balo ka kanang column, doon naman na siya i-load. Ang load sa column gikan sa mga floor sa building, itong weight sa tao. Mao na siya ang ultimate nga dito nimo makita ang ultimate nga weight sa structure dito sa column na nag-support sa puting. Now kung ang puting nimo nga simento is nipis kayo, siya mabuslot. Okay? Mabuslot. So, muna, magwa ko doon sa punching shear sa internet ha. Makikita ni punching shear. Punching shear. Okay, punching shear. Picture. kini siya nga picture. Ato lang ni pagawas din nato ni punching shear. Punching shear. Punching shear. Wala ako sa iya. Punching shear. Kita ninyo class? Na picture? Mao ni siya ang punching shear. Pero dili ni siya puti nga sa slab ni siya nga too much ang weight sa slab niya ang dunay reaction nga kulog pa sa taas akong butang. Naman ni siya reaction actually. Tawag niya ani reaction. Kabatlo man mo nga in every action there is an action. Nana siya diha ato ni siya format lang ha. Format. Okay. Mo na siyang reaction, no? Kung doon na kay weight sa paubos, nasa kay reaction equal. So, kini siya mo na siyang ni-punch sa slab lang ni siya, no? Ang may tabo sa puting ang good nga punching shear is yung ni puting. Sa puting mangita to sa puting ha. Ada nga puting. So, ipakita ang analogy sa puting ug slab. Sa puting mao ni siya ang punching niya, no? Itabo sa punching niya. Wag yun siya mabuslot, oh, kini. Baliktad sila, ano man, kaya mo man ni siya ang slab, mo ni siyang puting. Ang slab, ang load ni mo paubos, kung saan man ang load, mao na siyang load sa mga tao, mga deadweight, mao ni siya nga paubos siya, makita niyo din nga, paubos siya, no, kini. So, yeah, ang reaction sa column is going up. Kaya ang reaction always mo man ni siya, ang column may nag-support sa slab. So, kung nag-support ka, ang reaction paubos, pataas. Now, kung puting ka, opposite siya, no? Nga may tabo sa puting. So, dini gipakita ang difference between flat slab and ang analogy sa flat slab og puting. So, ang flat slab mo na siya ang puting. So, ang puting diya, ang weight niya, paingon di sa taas. Unsa man ang weight nga paingon sa taas, mo na siya ang passive nga weight nga naa sa soil mo. Ang soil nga, bag tubig ba? So, ano tata barko? Ang weight sa barko is going down. Ang buoyant force sa tubig is going up. Mo na siya ni buoy up. Mubuoy up sa barko. O mubuoy up sa imong weight kung nakas tubig. No? Kung nakas sa tubig, tata, mulutaw ka, no? Kung floating ka, di ka maglihok. So, doon ay buoyant force sa water kung paingon sa taas nga ni-equilibrate sa imong weight. So, in that way, float ka. So, not all can do that, no? May mga tao sa uban yung sinker. No? Sinker nga tao, no? Kung saan yun nila, munlod yun sila. So, what they will do is, they will inhale a lot of water, inhale a lot of air, put that diaphragm, so that doon na sila flotation gamay. So, maka-float sila, no? But the moment nga iya itong i-spill ang air sa diaphragm, unlod sila ginahinay. So, meaning sinker sila. Doon si tao nga naturally, floater gid siya. Lutaw gid siya. Pero kahoy ba, na-sinker na ay nasa floater. No, kung mga tugas, unlod ko sila, gan manbukat man. So, itong mga palkata, lutaw dito sila. No? So, yan na sila. So, the soil is just like a buoyant force. No? If the load is going down, there's a buoyant force. Now, this is the one that prevents. So, In other words, ingani ang itabo niya, ma-punch niya, no? Kung nipis kayo. So, kung there should be proper thickness nga dili siya ma-punch, no? So just like mo-punch ka og papel, kadyo to kay punch ang papel, kay karon man nipis man kayo. Itay gali nag-cardboard, nga dublihon pag gini mo kung dali ba nimo ma-punch. Dili. Kay nga naman, ang thickness do na nayo resistance, no? So, okay. Doon na mag resistance against punching. Pero kung gamay kayo, that's negligible. More kagaiwa o butter niya, init imong knife. No? Walay ka resist. Okay? But if your knife is cold and then the cheese is very thick, ang gahit pag sa freezer, di na mo mahiwa. No? Mahiwa nimo, but it takes some time. Okay? It's different. It has different effect kung knife. Yang imong ihiwa o mapapaso sa imong kamot. Kaya nga naman, init good ang knife. Anyway, so doon na sa itawag na punching. So to avoid punching, you are going to design the thickness of your building, no? So doon na tayo gitawag allowable punching shear, no? Ang allowable punching shear katulad yung gihapon sa kuan sa una kung 1/6 or 2 akong tanawon ha. Design of footing. Design of footing. Footing, chapter 20, 810. Okay, so natay gitawag nga BC to mo na lang ko na equation. Okay. Papong equation, insert equation. So, 2 is here. B is equal to 2 plus 4. 2 plus 4. Up to 8. Banda ini 1. Beta. Beta. Okay. 1. Then square root of f prime of c. F prime of c. Okay. Then doon na itawag na ito V subscript nga O divided by D. And this should not muna siya. Then upper limit din niya na this should be lesser than or equal. It should be lesser than or equal to 1/3. 1/3 of the square root of f prime of c v o d. Una yung upper limit, no? So mao na siya. Unya ang siya For one way, this is for two-way, no? For two-way. For two-way. Okay. So this is the formula. Okay. So for two-way shear, two-way shear. So for one-way shear, for one-way, so mao siyang one-way shear. Oops. Okay, so this is for one-way shear, no? One-way shear. So ako ibutang ang kuan ang kuan na niya equation from the ACI ko na siya. Mo na siya ACI 11.11.2. Mo na siya ang source niya ang equation. Nga pa so one-way shear mo lagi ako, no? Ini siya mo na siya. Sa ilang source. Okay? Next is design the reinforcement. Design. Okay, so once mo pasara na gali siya aning punching ug one-way shear, panalitan nagakuha ka og thickness aning duha. Ang isa 300 mm, isa 400 mm. You use the bigger thickness. So, duha ka thickness imong ma-derive ani. Use the thicker one, no? So design after that you already adapt the thickness that will not be punched or will not be broken by shear. You design the reinforcement, no? Reinforcement. How? By bending moment. Paano yung bending moment? Then number 4 is detailing na dayon. Detail of putting. Drawing na dayon, no? So dili na ni siya design, drawing na ni, ma-apply yung drawing that. So sa design sa moment, pag design mo sa moment, design for bending. Design for bending. Design for bending. Punching shear. Na pa isang klase nga shear. Itong dili punching one way, two way man na. So mo na siya, no? So balik ta. Anito sa klase nga shear. punching share design. Tapos punching share design. Ano siya? Ang one-way share. Type of one-way share. One-way share. One-way share in footing. One-way share. So this is what happened to one-way share. Mabali siya. What picture? This one is the dinding. Mga siya sa dinding. Ito po. Okay. Kuha pa tayo.
MRS.
So one-way share. One-way share. One-way share. May tatawag one-way share. Failure. One picture yun. One-way share. One-way share. Kaya. Ano yung failure sa one-way share? Ayan siya. One-way share. So, mabali, ma-share siya, mabali siya. The whole of this mabali. Mabali siya tungod sa kanipis niya. So, para malikayan nga mabali siya on this picture, you have to situate nga thick siya, no? Nga mapasar siya sa criteria sa formula sa one-way share nga, which is this one-way share. Okay. So, once you have already enough thickness, the next thing is you're going to design. Nganong butangan man ni ingon ani? Kay mo ba tungod sa load nga ni adinhi, mubaog ni siya mo ani. Tanaw nimo dito gyapon ta balik gyapon ta sa gitawag nga depleted structure. Unsa ka kabalo, unsa ka unsay masabtan nimo sa depleted structure. So, ngani ang depleted structure ani. Okay. So, kung ingana imong depleted structure, pangutan-on ka na po asa man dapit ang tensyon niya na. Ay, anybody ka nan, sir? Asa ang tensyon niya na? Nas taas, nasa ubos. Kung ingana imong depleted structure class, ingana ang building sa imong puting. Aha man ang tensyon na nasa ubos, nasa taas.
Ubos.
Ubos. That's why, butan ka og bottom bars. Okay, ang may tabuan na kung binda siya ya, too much binding na, doon na crack mo form. Okay? Kaya nga naman, ang binding moment niya na, kuhaan ang binding moment ana eh. Ani ang binding moment ana niyo. Kita tag binding moment ha. Wala may. Yan. Next episode. Anyway, ang shape sa binding moment ano niya yung nani. Ako ihatag ang shape sa binding moment ha. Nani ang binding moment niya. Tama o niya siya yung horizontal. Ay, tayo. Doon sa tawag kuhan. Nani. Nga, doon din tawag yung nani. Muna yung shape sa binding moment. proceeding nga na. So, mga na siya. Sana ang bining moment niya na. Maximum na sa support. So, what happened kung mubin yun sig tayo nga wala yung enforcement, sumukrak siya. No? And it's not good kung wala yung enforcement, kumukrak na ano man, ang concrete good, once mukrak, crack na gina siya. Pero kung nayo yung enforcement, dili ma-prevent na siya nga mag-crack. O kung magaling, dili siya mo separate from each other, still intact. So, that's why you need a bottom bar. So that's the overall design. Then once you know the requirements of the reinforcement in step number 3, that's the time you do the footing. So the footing detail is like this. Footing detail is like this. Footing detail. Footing detail. Footing detail. Design kundi ang inyong knowledge sa drawing ani mo importante. Draw ninyo ma-show ninyo in accurate way nga masabtan sa uban, dili lang ikaw nakasabot, masabtan sa reader, masabtan sa mga carpenter on how to actualize your detail. So this is the detail of footing. I'm going to show you what type of detail of footing. Detail of footing. Detail footing. Okay, detail of footing, picture, image. So, hinalay na mo labasan na niya. Kini, no? Ato kini, lalipas sa itong leksyon kay ano, nag-provide siya og one ng top reinforcement. Okay, ni. So, doon na kay detailed footing ngayon na ni. This is the last. So, mabuhat lang ni mo ni kung na kay step 1 katong size footing na kay length to width ani. Nya step 2 mo kuha mo ang thickness. Sa step 3 mo kuha mo ang reinforcement. So, makadun na rin ka o plan and elevation of your footing with width, with thickness, and the number of bars. So that's how you are going to design a footing. No? So, ni siya, no? So mag-break sa ta class ha. Ako ni siyang isugod og butang sa inyong e-learn para makuha sa inyo. Stop share sa ako lang sa ning ibutang sa e-learn para ma-download ninyo, no. Ibalik ako mga 15 minutes no mag-break pa sa ta. Stop sharing. Okay. So, madto ko sa Google. Okay, so mao to siya, imo na kung upat ka step.
Excuse me, sir.
Yes.
Kanang karon 9 AM, sir, ba kay nag-start na ang engganyo sa ACES. If maka-join ka, sir.
Lagi mo join ko. Anyway, ako lang siya i-send, no. Kuan lang ko, makikita lang ko sa inyo niya mga about 10:30. No? 10:30 ta magkita sunod, no. Kaya ako to yatag sa inyo katong activity ninyo sa laboratory. Maka-word to siya, no? Naka-document na to siya. Ito pa. And the deadline will be next week, no. I have to give this today because we are run out of time already. We have a time only for discussing columns, no. And, so as for the example of this, I will just put it, no, in the e-learn, no. It will follow, no. So nga na lang. Any other? So everything I discussed, I put it in the A-Learn, and then at 10:30 I'll meet you shortly to give the laboratory activity. So that's the plan. Okay, thank you.